Chapter 4 Test and Concurrency. Objective: identify the basic components of a test and context test and process. Describe the benefits and challenge of design multi-test application. Interest in illustrate different approaches to implicit testing, including test tools, fork join, and grand central dispatch. Motivation: most modern applications are multi-thread. Thread run within application. Multiple tests with the application can be implemented by separate thread process. Creating is heavyweight, while thread creation is lightweight. Can simplify code, increase efficiency. Benefits: responsiveness, and allow continued execution if part of process is blocked, especially important for user interface. Resource sharing: share resource of process easier than share memory or message passing. Economy: cheaper than process creation, test switching, lower overhead, and context switching. Scalability: process can take advantage of multi-core architecture, multi-core programming, multi-core or multi-processor system, putting pieces on programmer. Challenge include dividing activity, balance, data splitting, data dependency, testing, and debugging. Parallelism implies a system can perform more than one task simultaneously. Concurrency support more than one task, making progress. Amdahl's law: identify performance gains from adding additional core to an application that has both serial and parallel components. S is serial portion in processing core. User test and kernel test: user test management done by user level test library. 3 primary test libraries: POSIX, pthread, Windows test, Java test. Kernel test support by the kernel. Example: virtually all general purpose operating systems, including Windows, Linux, Mac OS X, iOS, Android. Many to one. Many user level tests map to single kernel test. One test blocking cause or to block multiple tests may not run in parallel on multi-core system because only one may be in kernel at a time. Few systems currently use this model. Example: Solid thread, GNU Portable thread. 1-to-1. Each user level test maps to kernel test. Creating a user level test create a kernel test more concurrency than many-to-one. Number of threads per process, sometimes less reduced to overhead. Example: Windows, Linux. Many-to-many model allow many user level threads to be mapped to many kernel threads. Allow the operating system to create a sufficient number of kernel thread windows with the thread fiber packet. Overrides not very common. Two-level model similar to M except that it allows a user thread to be bound to kernel thread. Test library. Test library provide programmer with API for creating and managing tests. Two primary ways of implementing library entry in user space. kernel-level libraries supported by DOS. P-threads may be provided either as user level or kernel level. A POSIX stands API for test creation and synchronization. Specification, not implementation. API specifies behavior of the test library. Implementation is up to the development of the library. Common is Unix operating system. Implicit threading growing in popularity as number of threads increase program correctness more difficult with explicit thread creation and management of threads done by compiler and runtime libraries later than programmer. 5 method explore, thread pools, Foxjoy, OpenMP. Thread pool create a number of threads in a pool where they await work advanced usually slightly faster to service a request with an existing thread than create a new thread. Allow the number of threads in the application to be bound to the size of pool. Windows API support thread pools. Signal handling signals are used in Unix systems to notify a process that a particular event has occurred. A signal handler is used to process signal. Signal is generated by particular event. Signal is developed to a process. Signal is handled by one of two signal handlers. Default user defined. Every signal has default handler that kernel runs when handling signal. Use defined signal handler can override default for single thread signal developed to process. Thread cancellation terminating a thread before it has finished. Thread to be cancelled is targeted to general app process. Asynchronous cancellation, deferred cancellation. In working thread, cancellation requires cancellation, but actual cancellation depends on thread station. If thread has cancellation disabled, cancellation remains pending until thread enables its default type is defined. Windows